We just saw that if y equals f of x is a one-to-one function, then we can define its inverse function, y equals f inverse of x, as a function that undoes the operations of f. That is, if we first compute f of x, and then compute f inverse of that output, we're right back to the original input, x. And similarly, if we first compute f inverse of x, and then compute f of x, we're again right back to our original input of x. Now, before we study how to compute inverses, let's try to get a better understanding of this function. Since f inverse is a function, it must have a domain and range. The domain of a function is the set of input values, but the input values of f inverse are the output values of f, which means that the input values, the domain of f inverse, is the range of f. So what we found is that the domain of f inverse equals the range of f. And since f is the inverse of f inverse, we have that the domain of f equals the range of f inverse. We are now ready to give our formal definition of an inverse. If y equals f of x is a one-to-one function, then y equals f inverse of x is the inverse function if x equals f inverse of f of x, the domain of f inverse equals the range of f, and the range of f inverse equals the domain of f.